My name is Vega Tariyal, and today I'll be presenting Physics Lab 4, Oscillations. The purpose of this lab is to observe an object as it swings in an arc-like motion while oscillating on a spring, and then compare the computational model to observed values. Glow script was used for the computational model, and tracker was used for the observational model. Here's a brief overview of the result. On the bottom over here, we have the y position versus time, here with the x position versus time, and this is just the change in energies. Some fundamental physics principles. First, we have the momentum principle, and then we have the potential gravitational energy equation, the kinetic energy equation, and the potential spring energy equation. These all come from the momentum principle, and they'll be important in this lab. And then also the velocity update formula and the position update formula will be important to calculate the motion of the object in the computational model. And then the energy formula. And for our lab, there will be no object surroundings, and everything will be in the system, so therefore the total change in energy of the system will be 0. And it will equal the change in potential energy plus change in kinetic energy plus the change in potential spring energy. And then in this lab, the system includes the object, the spring, and Earth. And then in the surroundings, there'll be nothing because the work done by the surroundings is 0. And then to begin this lab, I uploaded the provided video into Tracker and extracted the position data. Then I added the started code using the pre-lecture video. When running the program, I inputted a CSV file containing my observed values so I can compare the differences between the observed and predicted values. So for step 1 of the lab, I uploaded the given video into Tracker, and then I tracked it. And then on the right, we can see the x values and the y values over time. And then I'll use these. I use the first row for the initial position, and then the first 2 rows for the initial velocity. And then here's the code for the second part of the lab. This ball mass, delta T, the spring constant, and L naught, and then L, and S were all given in the pre-lecture video. The initial position of the ball and the initial velocity was calculated using the first row and the first 2 rows, as I just said. And then these equations are the ones that I put in the fundamental equations. And then F grav is just mass times gravity, and then spring force is just negative K times S times L hat, and then the net force is just all of the forces together. And then I put here the update velocity and update position formulas, and then these 3, L hat, and S, were again from the pre-lecture videos. And then this is just again putting the equations in, and then to find the change, it's just the final minus the initial. And then for E, again, it's kinetic plus potential gravity plus potential spring energy. And then here's the graphs from Glow script. You used to change in position in Y over time, change in position X over time, and then this is what the model looked like. And you can see that the change in X was pretty much exactly the same as the model, and the experimental work pretty much exactly the same. And then for Y, it was almost the same, but you can see it kind of peaks a little bit higher in the computational model. And then some possible sources of error is human error. When I was clicking the object in Tracker, it's pretty easy to misclick it. And then there could have also been some errors in the code. And then is the energy principle satisfied? So the energy principle says that if there's no work done by the surroundings, which is what we're doing for this lab, then the total change in energy of the system will be 0, and then delta E is orange, and you can see it's 0. Don't worry about all the other lines the TA said. It's fine for the lab. And then using the data I obtained in Tracker, I was able to find the period of oscillation using the x values and the y values. I just found two places where the x values were equal, and I found the change in time between them. And then same for the y, I just found two y values are equal and found the change in time. And you can see they're a little bit different. And again, it could have just been from like misclicking the object in Tracker. Thank you.